Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, today's topic was inspired by a conversation I had with a customer a few years ago when they were interested in coming up with an algorithm so they could calculate how long their OCS all-in-one controller had been powered down. So that was an important aspect of their application. And it was an interesting problem that we worked on solving at that time. Now, since then, there have been some other interesting questions regarding time. So that led me to today's topic, and that is time math functions. So what is time math, and what are some of the problems we can use time math to solve? Well, we're going to answer those questions today with today's topic. Now, I am flying solo today because I did have to pre-record. Nate Beachy decided that he was going to put on a remote training class this week up in the wilds of Canada, and that happens to be the same week that we have advanced training scheduled at the factory. So as I'm the backup training instructor for factory training, I'll be called into action, which means pre-recording today's video. It also means I won't have a chance to bring Casey Gardner in today and talk about his time off and how that new addition to the family is doing. So we'll hopefully get to that next week. All right, let's take a look at how we're breaking down today's topic. Okay, so we're breaking down the topic by starting with what is time math? We're going to answer that question. I don't think you'll find time math in the dictionary, or if you Google it, or at least you may not find my definition of time math if you Google it. But we're also going to answer some other questions. How would you calculate not only how long has the PLC been powered down, or how long has the OCS been powered down, that third one on the list there, I've already mentioned that's one of the ones we're going to solve today. But here's a couple others. How would you calculate elapsed time from a start and end date? How would you calculate end dates from a start date and a duration? And for all three of these particular questions, what are some real-world examples of applications which could really use this information? And of course, we're going to have demonstrations throughout, as we always try to do here on the channel. Okay, let's start with the Chuck Ridgway definition of time math. So what I'm calling time math is any calculation involving time where either the hour, minute, seconds, or month, day, year format, or both of those things are involved either in the input of the calculation we're trying to do, or the output of the calculation we're trying to do, or maybe even of both. Okay, and some examples of time math that I'm showing here are, what is the projected service date for this machine? How many days has it been since this machine was maintained? And how long has this machine been powered down, so I can decide what kind of startup procedure I want to use, for instance. So these are all real-world questions that we're going to answer today using time math. Okay, so the next question is, why is time math challenging? It doesn't necessarily on the surface seem like something that would be that difficult. Well, when we're using PLCs or Horner OCS all-in-one controllers, almost always when we're talking about time, we're using some sort of a timer or a counter to keep track of an interval. And that's a pretty straightforward operation that those of us who are control system programmers have done literally thousands and thousands of times during our career. However, timers and counters don't perform calculations. So if you've got a stored away date and an interval and you're trying to calculate a future end date or something of that nature, you can't use a timer or counter for that. You're going to have to do some calculations and write some logic in your program. And what you'll find is, when you start thinking about it, is that if you need to format, let's say, a total number of seconds, maybe an output you did get from a timer or a counter, and you want to format that into hour, minute, seconds format, there's more programming than you would think, just because of the nature of the way time is formatted and stored. And if you're involving dates and years and months, it requires even more effort. You know, if you think about some of the idiosyncrasies of the calendar, you know, the fact that you've got different number of days per month. You've got leap years that happen some years, giving you an extra day, and other years you don't. All these factors mean that time math, if you're just going to program it in from scratch, can definitely be challenging, and it's not as easy as we might think on the surface. Okay, so we're going to start solving these problems, and one by one, and I'll introduce to you as we solve each problem a user-defined function block which we've created that you can download from our website that will allow you to easily solve these problems in the future. Okay, so let's take a look at our first problem, and that is calculating an interval from a start date and an end date. And here's a real-world application for that. Okay, so let's say that you've got a machine being controlled by the Horner OCS, and there's a formal preventive maintenance program that's part of the information that's displayed on the Horner OCS screen. And in support of this PM program, we wanted to be able to display on the screen the number of days, or maybe even the number of hours, since each particular machine system has been serviced. So this is a pretty common thing, really, right? We know the service date. Okay, when service was performed, that was recorded, maybe captured from the real-time clock on the screen at some point when the service has been performed. So we know that, and we know what the date is right now, and the time and date is right now, so we should be able to display on the screen effectively what the interval has been since that last service was performed. But again, when we sit down and just try and do this from scratch, we find it's a lot more work. So let's take a look at this first user-defined function block that we've created, and this one will help you solve this particular issue. All right, so let's take a look at that UDFB there on the screen. And effectively, what this performs is this. When it's enabled, it will calculate elapsed time, or the time interval, between a start date and an end date. And the way that it, basically the way that enumerates that elapsed time is it's going to provide information in days, hours, minutes, and seconds between those two dates. Now, if we're talking about this particular example, where we're talking about, how many hours or how many days has it been since we last performed service on this particular machine function, then maybe all we're interested in is days. Or maybe for some frequently serviced type systems, maybe hours is what we're interested in. So we may decide to completely ignore hours, minutes, and seconds and just throw that information away, or maybe ignore everything but days, for instance. But regardless, the information we're going to need to solve this problem is available with this user-defined function block. Now, the next question you may ask is this. Well, if the inputs to this UDFB include start time and end time, what kind of variable format do I need to use for those two inputs? And what we have done, or what this UDFB requires, is for each start time and end time, it requires that you use a variable array of the integer type, dimension of 6. And each element inside that array for both start time and end time corresponds to second, minute, hour, date, month, and year. And the reason that particular information is required and in that particular order is because that lines up with the data and the order that the Horner OCS real-time clock uses in its system register memory starting at SR44. That makes it really easy for you to effectively capture a particular start time or end time using the real-time clock. So what I'm showing on the screen here is I'm showing that the end time of this particular UDFB on the screen is a variable called current_RTC. So again, we know the start time of our last service date. We know the last service date, and we're trying to see how many hours or days it's been since that service was performed. So the end time for this case is always whatever the current time is. So how did I create that current RTC variable you see there on the screen? Well, if we look down at the program variable table at the bottom, you'll see I've created the variable, assigned it as an unsigned integer type with a dimension of 6, so it has index from 0 to 5, and it's mapped to memory location %SR44. So that means SR44 through 49 will effectively fill in the 6 different unsigned integer elements of the current RTC variable. And that makes it really easy to capture the current time using that approach. Now, let's say for the start time, how would we capture the start time? It's shown there with a variable name of last service. Well, elsewhere in my program, I could have, maybe a button on the screen that is pressed right after the service is performed, maybe by the maintenance person, and that single rung that is activated by that push button on the screen could capture the current time and store it away using a block move and store it away to the variable called last service. So again, it's real easy to populate these particular variables because they mimic the format of the Horner OCS real-time clock. Okay, so the next thing we're going to do is I'm going to demonstrate this particular UDFB and show it to you on the bench. Okay, so here's my example program with my elapsed time UDFB already placed in the program. Okay, so first of all, how do I make these UDFBs available in my project to begin with? Well, the first step is, of course, after you download the files from our website, the UDFBs are in the form of .cpu files, okay? So the first step to use them in your project is to go to the Logic Modules section, right-click, and say Import Logic Module. And then you navigate to the particular folder where those CPU files reside that you've downloaded. And then once you've added those in, okay, then they will show up here under UDFB modules. You can see elapsed time there. And then when you want to drag them or put them into your program, they show up in the toolbox under UDFBs. Okay, so that makes it easy. So you just grab them, drag them on your program. The first thing it'll do is it will ask you for the instance name. And in my case, I created an instance name of duration for this UDFB because I can have multiple instances of a UDFB in my program. That's one of the powers of UDFBs. And then if you take a look at the program variable window after you've dragged that on the screen, you'll notice that you'll have an entry, in my case, under global variables, for the name of your UDFB instance, as long as the type of the UDFB, which in my case is elapsed time. Okay, so really all I've done here for my example program, which you can also download from the website, is I've assigned start time, end time, and I get the output. And really what I'm doing here, if we take a look at my screens, is I've created a test screen where I can plug in a start date, an end date, along with hours, minutes, seconds, of course, and then hit the button for enable to enable this function block, and it'll spit out what that duration has been in days, hours, minutes, and seconds. Okay, so that's what we're doing here. And let's take a look at it on the bench. Okay, so as you can see in the center there, I've got a start date and an end date, and right now it's just set to January 1st of 2023. And on the right there, that is the output of our function block, which is days, hours, minutes, and seconds. All right, so let me go ahead and just start simple. Let's add a day to the end date and see if we get the proper results. And we do, of course. That's a very easy calculation. All right, let's go ahead and make it a little bit trickier. Let's go ahead and let's add a year to things. Now you'll notice my calculation didn't update, and that's because I never turned my enable off. And the function block only operates on the leading edge of the enable. So it's not going to recalculate this until I turn enable off and then turn it on again. Okay, so you can see it's been 366 days, or 1 full year from January 1st to January 1st, and then an extra day with January 2nd. And if we were January 1st to January 1st, we'd be at 365. Let's do that now. And we are. And then if we extend it another year to 2025, let's see what happens. Okay, we get 731 days. Why is that? Well, because 2024 is a leap year. So we've got 365 days in 2023 and 366 days in 2024. And, you know, if we vary the hours and the minutes and the seconds of the start date and the end date, that will also show up in the calculation. I just didn't choose to do that here in the demonstration. Okay, so really what we've done is we've taken what's a tricky calculation, and using this UDFB, we've made it very, very simple. Okay, the next problem we're going to solve is similar to the one we just solved, but different. And that is this. So let's say we have our preventative maintenance program, and this time to be displayed on the screen of the OCS is not necessarily how many hours or days it's been since the last service date, but what if we want to project what the next service date will be? Okay, so again, we know our last service date, that was captured and displayed maybe, and we know the recommended service interval for this particular element of the machine. So maybe it's 1,000 hours or 150 days or whatever that recommended service interval is. We know that plus the last service date, and our task at hand is to project the projected service date or the next service date and display that on the screen. Okay, so to solve this particular problem, we've actually created two user-defined function blocks, one of which you would use if the interval that you're trying to use or that you need to use is in terms of days. Next service is in 150 days. We have another one that you would use if that interval is in terms of hours, maybe 1,000 hours before the next service. Okay, so in this scenario, again, when you enable these function blocks, it calculates the end date for you in hour, minute, second, date, month, year format based on a start time and the interval. And again, the interval is either in days or in hours, depending on which UDFB you use. All right, so let's go ahead and demonstrate these particular UDFBs on the bench. Okay, so here's our demo using the add days UDFB. I'm only going to show you this one. The add hours UDFB is very, very similar, so we don't need to demonstrate that one separately. Again, because I imported this UDFB by right-clicking on Logic Modules, it shows up here in my toolbox and allows me to use it in my project. Okay, so quite straightforward. Again, I set this up very similarly to the last demo that we showed you. So again, with this particular user-defined function block, the input is the start time and the number of days that I have as an interval, and then the output of this function block is the projected date or the actual date that will result from adding this number of days to this start date. Okay, so that's what it looks like. Again, not much here on the screen, very straightforward in terms as the program goes. Let's go ahead and head to the bench and take a look at this one. Okay, so very similar demo to what you saw before. What we have there in the center is the start date that I'm starting my calculation from. And then in the center, or to the right of that, is the number of days I'm going to add to that particular start date. And on the right is the end date that I end up with. Now, one thing you'll notice there on the end date is you're seeing right now, I haven't done any calculations yet, but what you're seeing is an end date of 1/1/1996. So what's that all about? Well, when we perform a clear function, in other words, to clear out whatever the previous calculation was, when I hit that clear button, it doesn't just set everything to zeros, it actually sets it to the default real-time clock date, which happens to be 1/1/1996. So that's just how you know that you've got, just default information in there and not a real result is you'll see the end date of 1/1/96. All right, so let's go ahead and perform a calculation. Let's just do something simple to start with. Let's add 7 days to our start date and see the results. Okay, and there we go. We've got a end date of the 8th, which is obviously very easy to calculate. All right, now let's do something a little more challenging. Let's add, let's say, 100 days. Okay, and that is April 11th is the date that that's going to be in this particular year because, again, 2023 was not a leap year or is not a leap year. So we didn't have that extra day in February, whereas if we did, we would end up with a different result. So let's go ahead and let's change the calculation. Let's do 100 days from January 1st of 2024 and see what we get. As you can see, we get 1 day earlier because we've got that extra leap day in there as February 29th. So again, this particular UDFB handles the leap year properly and the leap day properly and gives you the results that are accurate. Let's go ahead and hit the clear button just to demonstrate for you what happens with the end dates when we do that. Once again, it goes to the default real-time clock date of January 1st of 1996. Okay, and as I mentioned before, the add hours UDFB is extremely similar to this. You simply add in the hours as your duration instead of days. Okay, the final problem we're going to solve today is the one I talked about during the opening, and that is determining how long a machine has been powered down. Now, many of you may have been racking your brains thinking, why in the world would you ever care how long a machine has been powered down? Well, let me give you a couple of examples. So one example I have there on the screen for you, and maybe that's a scenario where you've got a piece of seasonal equipment or some seasonal machinery, and it's only powered up sometimes. And depending on how long it's been powered down, you may need to change the startup procedure so that it will operate properly when you need it. So maybe it's agricultural equipment or some other type of equipment that's used seasonally. Another example might be some sort of process. Maybe you've got a fairly complicated process going on, and if you lose power during that process, when you power back up again, what you do with that machine control is going to vary based on how long you were powered down. Maybe if it was just a brief glitch of a couple of seconds, you just pick right up where you left off. Maybe if you were off for longer than that, you need to go through some sort of complicated shutdown procedure or complicated procedure of, throwing away effectively the material that's being used in that process, or somewhere in between. So there's a couple of real world examples of where you may need to solve this particular problem. So we've created a user-defined function block, very easy to use, that you can throw in your program and it will give you this information. So this power off time UDFB, one of the things that's interesting about that is that it doesn't have any inputs. So you just connect it to the always on contact in your logic. There's no other inputs, and it will tell you how long it's been or how long in duration that previous power cycle was before the unit powered up this time, okay? Now, it doesn't have any inputs because it's taking advantage of the real-time clock and other system bits and system registers that it needs to be able to, as inputs, to make this connection or to make this calculation. And then the output it provides is two things. One is it provides a total number of seconds. So if all you're interested in is seconds, it'll tell you, oh, it's been 15 seconds it was powered down, or 30 seconds it was powered down. Or if it's been a month, it would be a month worth of seconds in that total seconds output. And that's a double integer value because those numbers could get big. And then it also provides you days, hours, minutes, and seconds as well, if that's a format that you're more interested in. So again, whichever outputs you're interested in, you can assign variables to them that are important variables in your program. For the ones you don't care about, if you don't care about some of them, you still have to assign variables, but they might just be junk variables that you ignore elsewhere in your program. Okay, so this is the power off time UDFB. And next, let's take a look at this one on the bench as well. All right, so here's my example program that I've got. And again, this is a program you can download along with all the UDFBs that we're posting today. And it's right here is this UDFB, and this particular instance I've named downtime. All right, now, as you can see, it's very simple to set up. It just needs the always on contact at the beginning like the other UDFBs do. And then it has these 5 outputs. So the first output is that total number of seconds, which can be a big number if it's been a long downtime. And then these are the number of days, hours, minutes, and seconds. That's the other format it provides. Okay, and there's really nothing required other than what I'm showing here in the screen in order to make this work. Now, in my example program, of course, I've got some extra rungs here so we can have some screens with some content and demonstrate it and all that sort of thing. Okay, so what I'm going to do next is I've had my controller powered down for a long time before I recorded this particular segment. So I'm going to show this to you in action. So let's go ahead, and I'm going to go ahead and power up the controller now for the first time in a few hours, and then switch to the overhead view. Okay, that's going to come into focus here. All right. And here we go. We're going through the startup process. All right, and on this particular screen, I'm showing how long it's been on the right-hand side there. I'm showing how long it's been since the last power down. So as you can see, that first number, total seconds, is very large. So it was 53,341 seconds since the last power down. Now, why is that information important? Well, for an application like that process I was talking about, maybe you're just interested in knowing, hey, if it's been less than 90 seconds, then we do this. If it's been less than, maybe an hour, which is 3,600 seconds, we do this in terms of how we react to that power down. But if it's a larger number than those two numbers, then we're going to have to throw away our batch or something like that. So in that scenario, you're just looking at that first variable only. Now, in another scenario that we talked about where we have equipment that's used maybe seasonally or periodically, in that scenario, you're probably more interested in how many days or how many days it's been or weeks it's been, for instance, since the equipment was powered down. And that's why the days field, along with, hours, minutes, seconds, are also reported, why that would be more important. And then, of course, I've captured the time of that power down and the time of the power up there in the center so that we can see what the start time and end time were there for this particular case. All right, so this is the third and final UDFB problem that we're solving, and that is how long the system was powered down. Okay, so that's our topic for today. Don't forget, you can download these time math UDFBs from our website and take advantage of their capabilities and the easy button that they create to solve these kind of tricky problems in your next project. Okay, so this is the portion of our program where I remind you we're here every Tuesday at 2 o'clock with a fully live show or a pre-recorded show or somewhere in between, but we've always got people standing by to answer any questions you might have on the topic. If you're watching live, if you're watching on replay like a lot of you do, give us those comments and questions in the comment section. Now, this year we're celebrating 10 years of the Horner Lighting Group as 2023 comes to a close. So don't forget to go to our YouTube channel and not only check out the great automation content, but the great Horner lighting content as well. Now, don't forget that we put on factory training pretty frequently at Horner. Now, we just so happen to be putting on the very final training class of 2023 this week, which is why I'm pre-recording. But don't forget to check out next year's schedule, which we'll be posting on our website very soon. Next week, we have a great topic for you. So one of the most popular web SCADA type products on the market today is ignition from inductive automation. And one of the best ways to connect your Horner OCS all-in-one controller to ignition is using a push protocol that we've covered before in the channel, specifically MQTT spark plug. And next week's show, we're going to zero in precisely on the steps that are required to establish that connection between the Horner OCS pushing data to ignition. So you won't want to miss that program. Okay, if you haven't done so already, don't hesitate to subscribe to our channel. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week, let's all get out there and do us some good.